going around and exams and everything. So hopefully everyone's fine. So today, what I want to get into more is some of the things that we can utilize in ROS when we start getting into bigger and bigger networks. Right. So up to this point, we've been looking at, we have one node that's maybe publishing something, and then another node is listening to that. Right. So it's interesting, and it shows us the key things about ROS. But really, where we get into the power of it is when we look at bigger systems. Right. So let's take, for example, if I had a robot in a warehouse that I wanted to go around, and it's going to go to different locations, and it's going to maybe at that location, something's going to drop into it and it's going to take it to some location, right? So I've got one node that's maybe controlling the wheels of the robot. I've got one node that's going to be receiving maybe the goal locations, so doing the path planning to get to that, which means that there's another node that's going to figure out what are those goal locations that it needs to go to and sends it. And of course, the robot, there's going to be odometry error. So you're probably going to also have QR codes or something like that in your warehouse to verify if you've gotten to the correct location. So that means you need an RGBD camera to process that data. You're going to need a node to do that. And you're going to have another node that's going to do your AR tag detection, right? And you're also probably going to have, people walking around. So you're probably going to want a LiDAR sensor. And with that, you have obstacle avoidance, right? And so, in addition, what if I want, say, 10 of these robots in this one warehouse, right? So their rough estimate, I've got a minimum of 70 nodes to start with, right? So with ROS, we can do that. We can have all of these nodes. And because we use things like object-oriented programming, right? If I have 7 robots, I write a node which can do camera processing. So I can have 7 copies of the same node that I've already written, and I can just utilize that class that I already have, right? But then what we're going to see is that can also lead to some problems, right? So if I have 5 cameras trying to publish to the same topic, how do I know what camera is doing that publishing? And is it going to interfere if robot 2 says, I need to go here, and robot 1 hears that and starts going there too, right? So how do we actually start dealing with this scalability when we start having more and more of these nodes? And so we're going to see some different ways that we can handle that. Right, so first thing we're going to do is explore a little bit parameters. We've alluded to them a little bit. So we're going to look at those in a little bit more detail. And then we're going to look at these ideas of remapping and namespaces, which relate to that scalability factor. So first thing, you've seen I've used this a couple times, but now we're going to look at this a little bit more formally, is this ros-args. Right, so this allows you to pass some additional information when you're running a node. Okay? So ros-args, there's a few things that we might do with this ros-args. One of them is remapping, which we'll talk about later. And so what might be a little bit annoying is that they do have shortcuts, right? So probably when you're first learning, it's better to use the full term so you know what it is that you're actually doing. As you get more comfortable, you could, reduce down and use just the -R-P. But of course, if you're just learning, unfortunately, a lot of the tutorials, they just use the shortcut. So it's not immediately obvious what they're doing. So I'm going to try and be a little bit more explicit and actually use the full keyword. Right, so what remapping is going to let us do, and we'll talk about it a little bit more, is you can actually say, if say a node normally publishes to a topic named command velocity, you could actually change the name of that topic. And so you're remapping it to something else. You can also assign individual parameter values. Okay, so we'll take a look at that one explicitly, where you can have parameters associated with your node. And on startup, you can say, here's the value that I want for that particular parameter. And you might also have cases where maybe you have a bunch of nodes running and you get all the parameters that you like maybe for whatever situation it is that you're working on. What you can do is you could also save all of those parameters to a parameter file. And then when you start up next time, you could say, I want you to use the parameters in this file instead of your default parameters. Right? So it allows you to do that back instead of in the command line saying -p, parameter 1 equals this, -p parameter 2 equals that, and so on and so forth. You can simplify that by having a single file which loads all of the parameters for you. And then the other thing that you can do with ros-arg is the log level, right? So we talked about that before, where if you have a node which prints out a lot of maybe those info topics and you don't really care about that, when you're running it, you could say, I only want things that are a warning or above. I don't care about the infos. Stop printing it to my screen because it's annoying. Right? So you can do things like that. And that's also a ros-args. Right, so we're going to take a look first at parameters. So the slides are posted, but I'm going to mostly work in the VM rather than go back and forth so we can get an idea of what's going on. All right, so I'm going to use the turtle sim. And we have a turtle sim node. And okay. All right. So if I start my turtle sim node here, right, so we've seen this a few times now. I'm going to open another terminal here. So I can do a ros2 param list. And it's going to give me a list of all of the parameters that are available. Right? So the first line here is going to tell you the node that it's associated with. And then each line underneath that is going to tell you the associated parameters. Right? So if I have multiple nodes running, you would see a slash and name, all the parameters, a slash and name, all the parameters. Okay? So if I wanted to get a particular value, I can do ros2 param get. The first thing that you provide is the node name, right, which we can see right from there is turtle sim. And then I want to get, say, background. Right? So not only does it give you the value, but it also tells you what type it is too. So this is going to give you an integer, which is a value 86. So now if I wanted to set this parameter, right, so maybe I want it to be more green, I could say ros2 param set. I give it the node name. I give it the parameter that I want to set. And then I give it a value. And it's going to give you feedback. Yes, I actually did set that parameter. And you can see that it changes. Right? So one thing to note, right, so I change this background color like so. If I kill it and I reopen it, and it's back to its default color. Right? So when we set up parameters, we'll see in the example code, we always give it some default value. And so that's why those parameter files can be important when you're loading up nodes later, because it's not going to save whatever that parameter is. It's always going to default back to the original unless you explicitly tell it to use a different parameter value, right? So it can be good because then you're not overwriting your default, maybe if you're playing around, but it could also be annoying if you keep reloading something and you really don't want this to be this color. Then you have to make sure that you load the parameters each time. Or you actually go in and change your code if it's really that important to have a different value. Right? We can also say, then I want to change this color. Okay? So what I can do, if I want to save these parameters, is I can do a ros2 param dump. So I'm actually going to go to the desktop for now. So if I do a ros2 param dump, and I tell it I want the parameters for this particular node. Right, so one thing to note with a ros2 param dump, it is going to create this file in whichever directory you are currently in. Okay, so that's something that can be, a little bit annoying if you're somewhere, mixed in the middle of your workspace, right? It's going to create it wherever it is that you are. So generally, the best practice is in your package, right? So if I have something like my test workspace here, and if I am working with, say, my turtle nodes, you want to create a folder here that's called params, right? So then, all of your parameter files are going to be in that folder. And then it's a lot easier later on if you want to load those parameters, it's within that folder, so then you can access it later. All right, so let's take a look at this turtle sim here. Right, so you can see it looks just similar to when we looked at the parameter list, right? So it tells you here's the node, here's all the parameters, there's the like the keyword, the field, and then here's all of the values that we had at that time. So if I wanted to start my turtle sim with this color, then what I can do is I can do a ros-args with the params file, and then I tell it to use the desktop turtle sim.ym. And you can see that it loads the parameters that I saved previously. Right, so definitely useful when you have a lot of nodes that have certain setups that you want during that instance. Because one thing that's a little bit annoying is with the parameter files, you can have multiple nodes, right? So I could have within this YAML, right? I could have 10, 15 nodes listed here. With the param dump, you can only provide one node. So that's a little bit annoying, but you can go in and you could add to this file. And so when you're launching, we'll get to that next class, multiple nodes at once, you could have a bunch of node parameters all within one file. So it really helps clean things up when you start scaling up to larger networks. And so one other thing that we can also do is ros2, let's see, let me rerun this. ros2, param, and there's also a describe option. So turtle sim, let's say background G. Right, so this tells you what the name is, what type it is, right? So if you have integer, double, string, all of those. It can also tell you if there's any constraints associated with that parameter. So for this case, it's not going to let you provide anything that's outside of 0 to 255. And within that interval, you can only have increments of 1, right? Which makes sense with an integer. But you could also say maybe step of 5, so they could only provide 0, 5, 10, so on and so forth. And you can also add a description so that people have a better idea of what these parameters are actually doing. Right? So let's take a look at an example file. And so I went through and created this myself already. There's some instructions available on the PowerPoint. There we go. I'm going to go to my test workspace and it's source. Right, so I created a new one called Python parameters. Okay. So I just created this as a Python build type, right? So I meant Python, it has dependencies on RCLPY like we've seen with all of the other ones. And so within that, I created a new file. So we go into our Python parameters here called Python parameters node. So if I go into edit that, okay. So a lot of this stuff we keep seeing again and again, pretty similar between these different kinds of nodes. So let's look at what's different. Okay. So the first thing we notice is that now, similar to with actions or services where we inherited specific things from within RCLPY, say RCLPY.action, we inherited the action client or the action server. We do the same thing here, except now we're inheriting from the parameter area. And if we want a description, so when I did the ros2param describe, to be able to provide that information, we also need a specific interface, which is a message type, which is the parameter descriptor, right? So we need these two things if we want both of those. If you're not going to provide a description, then you wouldn't need this part. All right, so I initialize my node the same way we have before. The new thing here, right? So this is how you would define a parameter description. Okay, and we'll take a look at the parameter descriptor. There's actually additional things that you could provide there as well. For this one, all we're going to do is fill in that description field that we saw when we used ros2param describe. And then in theory, right, it should be something that actually gives you some information about that parameter. And then we actually declare our parameter, right? So how this works, our first one is the name of the parameter, right? So similar to how we had the name of the node type of thing. And then this next part is the default value, right? So one thing with parameters is once you define what type it is, it cannot be changed, right? So if you want this very explicitly to be a double type or a float type, right? If you just put 5 there, for example, it is going to define that parameter as an integer and will only accept integers, right? So with this declare parameter, it's going to look at your default value and infer from that what you want that parameter to be. Okay, so you want to make sure that whatever you provide is indicative of whatever type of value you actually want there. So in this case, it's going to look at this parameter, it's going to see it's a string, so it's going to assume that your parameters are always going to be a string type for this myParameter parameter. And then you can also provide the additional information from the descriptor. Okay. So one thing that you need to decide with your parameters is it a parameter that you can update while the node is running? Right. So if it's a parameter that you only want defined when you first start the node, then you do not need this part, right? What this timer is doing is it's going to check every 1 second, it's going to run this timer callback function, right? And so if we look at the timer callback function, what this is doing is it's getting this parameter that's called myParameter, and it's particularly getting the value of that parameter, and it's getting a particular field within that parameter. Right, so we'll take a little look at this in a minute to see what it is that this is doing. But the main idea here is that if you don't have this timer, then there's no way for it to check if you've changed the parameter. Right? If you want to be able to change it, then you need this timer in there as well, right? So something like the turtle sim, that's going to have a timer in there to check and see if you've changed the background color and keep it. Okay. There's also, another example of setting the parameter, right? So I commented this out because what this example is doing is every 1 second it's checking for a new parameter and then it's rewriting it back to the original, right? So I commented this out so we can take a look at it when we run the code. But if you add this back in, right, then this would be resetting that parameter. And then the rest of it is pretty much the same that we see every single time, right? So we start doing our main node, we initialize create the node spin that we see every time. Okay. So let's take a look at what happens when we run this node. Right, so I'm gonna clear this. And first things first, I gotta make sure that I source my workspace that I'm using. So we got test workspace. And I'm gonna open up a second terminal here. And we also need to source our test workspace here as well. Okay, make sure we have access to that new file. All right, so if I do a ros to run, and I want to do my Python parameters, and I'm going to run my minimal parameter node. And so what it's doing is just every 1 second, it's going into that callback and it's printing out the parameter value, right? Hello, and then world was our parameter. So I can take a look, right? Same way I did with my other example, right? So I can see all the parameters that are available to me. And I can see that if I do the describe, right? So we have our minimal param node, and we're looking at my parameter. Right, so we can see the description that I have here is actually available to us in the describe. If I hadn't provided that, then this would just be empty and I wouldn't get any information. Okay. So if I actually want to set the parameter, I can do my ros2 param set, and we have minimal param node, and I want to set my parameter, and I can set it to some value here. Right, and you can see that now this node has read the new parameter and now it's using that instead. Okay. So I can do the same things that I did with the other example. I can create a dump file with this value, and then I can load it up later if I wanted to initialize with this specific value. All right, so let's take and kill this here. And let's take a look at these parameter functions that we have that are new. I'm going to go into my Python environment, and from rclpy parameter, right, we had imported parameter. And to really dig into this, we unfortunately have to make our node, and we're also going to have to initialize. So in order to make a node, I have to have an rclpy init. So I'm going to make a new node. Let's just call it test for now. And within that, I'm going to declare a new parameter. Let's call it A with a value of 5. So now I want to see what we actually had when in our example code, we get parameter and we get parameter value. Right, so that wasn't particularly helpful. But if we do there we go. Right, so what's actually telling it is I'm looking for that specific function. Right, so we noticed that afterwards there was different types that we could provide. Right, so what can be a little bit confusing, right? It doesn't match the same int float that we've seen before in, say, our messages where we've defined things. So this is where it can be a little bit confusing. So that's why I've bring this up specifically is that if you're looking for a float type, then in your field you're going to have that double value. So a little bit different from what we've seen in other locations. Similarly, instead of an integer, right, instead of like a dot int or something like that, it's going to be a dot integer underscore value. Right, so similarly, we also have string, and you can also have arrays of values as well, right? So you can have a parameter which has multiple values within it. And so that's why if we do, there, say, next parameter, a dot parameter, right? So this is why there's that additional dot whatever here. And so it does kind of pre-populate everything as kind of default empties. So when you're looking for the specific parameter that you actually set, right, you want to look for that specific type, right? And so this first argument here is telling you which type it actually is. And so for ours, since we said our parameter is 5.0, so we essentially define it as a float, or in this case, a double value. Right, so a little bit different from what we've seen in other locations. But you can do this with different kinds of code, and you can see where it can be pretty powerful. So let's take, for example, my previously we had, say, ros2 run my turtle test turtle, right? So I had said before, a couple classes ago, that we did an example of an action where we did a trace square, right? So I could run in my other one here, ros2 run turtle test make square. So now, if I decided, you know, actually, I want a square of size 200, not 50, right? So as I wrote the code, the way to change that is to reopen the code, change the specific value, and then rebuild the whole thing, and then I can run it as a different size, right? For something like this, probably doesn't really make sense to do that. So what I can do instead is I can, and we'll take a little bit of a shortcut here, right? So my turtle test, I created a new version, and so I encourage you to try doing this yourself. And so what I said is instead, right, I'm going to import the necessary things to make a parameter. And I'm going to make a new parameter, which is the size of the square. And then for that, right, I can specify a default value. So in this case, I said 50 since that was the one I was using. And then within my goal, I can get that value and use it for my action, right? So you notice for this one, I don't have the timer in there because it probably makes sense that if I'm in the middle of drawing a square, I don't want to change the size of the square, right? So in that case, it makes more sense that you can only set it when you start the node. So that kind of shows that depending on what you want to be able to do with the parameters, that your code might change a little bit for each of those types of examples, right? So now if I wanted to, I can do a ros2 run of my turtle test, and I call this one param square. And I can say my ros-args, I want my param to be Let me make sure I have the right number of dashes here. That's always the annoying thing with these types here. All right, so param. That's not. And then we want to set our square size colon equals to actually define the value. And let's say 200, making sure that it's a float value because it's specifically looking for that. And so now I can draw a square of a different size, right? So instead of having to rebuild this entire code, go in and actually change it, now this gives me the flexibility where I could use this code, say connect it to 4 or 5 different turtles and have them all draw squares, but of different sizes, right? Because the size doesn't affect the underlying functionality of the code. So it makes sense that that could be a good place to put a parameter. Okay? So that kind of gives us the overview of what parameters are. Like I said, this is a good test case for you to try and add this additional parameter to that example that we worked with before. Right, so now you can imagine if I had multiple things running at the same time, right? How do I make sure that I'm communicating to the correct things? And so this is where the first idea that comes in is the idea of remapping. So let me kill this here. And so let's say that I do in one terminal, as we're going to have 3 terminals going here. So bear with me here. I'll try and minimize all the stuff that we have to look at. Okay, we're going to have 2 terminals which are running nodes, and then a 3rd terminal where we're going to interact with stuff. So right, so you can see as I get more and more stuff going on, this gets more and more cumbersome. So we'll see why launch files that we'll talk about on Friday are really nice because they can run all of these things simultaneously with one line instead of doing this, right? But so let's take, we have one turtle sim and turtle sim node. Okay, so I have my little turtle sim 1 here, and in my next terminal, I'm going to run ros2 run turtle sim, and we're going to have a turtle sim node, and I'm going to use my ros-args, and I'm going to do a remap. Okay, and so some of the things that you can do in the remapping is you can change specific topic names, and you can also change the name of nodes. So I'm going to take this other node and I'm going to give it a new name. And one thing is that if you want to have multiple remappings, you have to have multiple remap keywords, right? So for each remapping that I do, I need an additional remap. And then let's say I want to remap the command velocity of my turtle to something new. All right, so now I have two turtles going on here. Unfortunately, with the way the scaling is when I full screen this. So this orange turtle is my turtle 1 here, and this blue one is my Uguay turtle. So if I do a ros2 topic list, right? So we can see we have these turtle 1 topics, and we can see that there's this other topic here that came from my remapping. Right? So I basically called it something new. So we have this new topic here that's related to the command speed, but has a different name. Okay. So now if I was to say ros2 topic and I want to publish to turtle1 command velocity, and it's going to be a geometry messages twist type, and we have, let's say we just have it go forward for now. And as you've learned, the spacing issue is annoying. Right, so I publish to there, and I can see that because I published to the turtle1 command velocity, which is what that one is connected to, it moved the first turtle. And if I instead publish to the topic, so for this one, we have Uguay's go speed. Right, so now that one moves the other turtle. Right, now if I do say ros2 service list, right? So we can set also, we have this turtle1 set pen that we want to use. So I can use a ros2 service call of turtle1 set pen. We have turtle sim set pen, and I'm just going to make it a red line. Okay. So now I move my turtle1 here, and probably make it turn. Actually, let's just make this negative. I could go back. I definitely did this earlier today, and I apparently screwed something up when I was typing it. But what's going to happen is that because both of these are connected to the same service, is going to change the color of both turtles, right? So what that would mean is that if I truly want both of these to be completely independent, I need to remap every topic and every service within that, right? So maybe not the best, right? Because we want them to be able to act independently. So what we can actually do is we can utilize namespaces, right? So what namespaces allow us to do is to collect nodes and topics underneath this namespace so they can be interacted with independently of the same named nodes in a different namespace, right? So for example, with kind of the idea of multi-robots is that you could have like that initial example that I gave with a bunch of robots in a warehouse. They all have the same names for topics and for nodes, but each one has its own namespace that it exists in. So if you want to interact with one of them in particular, then you specify the namespace and use that for your interaction. All right, so let's take and kill these two nodes here. And so I'm going to restart a new turtle sim and a turtle sim node. All right, so this one's just my default here. And then for this other one, I'm going to specify that when I run it, I want to have my ros-args remap. And so underscore underscore ns is going to specify the namespace. And so I'm going to give this one its own namespace. Doing this last night. All right, so I need to figure out why that's not working because I swear that's exactly what I did last night. But you can actually map it to a different namespace. And so what the namespaces are going to change in the instruction is when you do something like your publish, then you have your topic, right? So you have the node turtle1 and the topic name command velocity. And so before that, you would have your namespace, right? So I can specify if I just do set the turtle1 command velocity, it's going to move the first turtle sim. And when I do my other one, it's going to change. When I have Uguay in front, it's going to change for the second turtle sim. And I'm going to try and figure out why this is not working because, like I said, I was just doing. Okay, one underscore. My bad. One underscore ns. I think it's double for node, one for namespace, which is annoying. Right. So now I have a new namespace Uguay. And so if I do say a ros2 service list or ros2 right, so you can see that we have the same topics, but these are going to be in a new namespace. So let me see if I can do, I still have my ros2. So we have a turtle1, command velocity. So let's take and do something like this so we can keep it on our screen. Okay, so I'm going to review this and update my notes. I don't know why this is not working. But what happens is you do change the namespace, and so then when you access, and I'll pull up the slides here, right? So there's some namespaces, right? So when you actually set the namespace, and so you give it whatever name for that namespace, and then when you go to actually publish to the topic, you're going to include the namespace in there, right? And so what this allows you to do is to actually separate out all of your different collections of these nodes, right? So like I said, in theory, you could have, say, 5 or 6 different robots. They all exist in their own namespace. You can reuse the same commands, right? The same topics and message types, but this allows you to separate them out so you're not interfering with your other nodes. And you can also, another thing that is possible, if we go back, because I was kind of falling off there into the slides, there's also this idea of a domain ID. Right, so the domain ID allows you to group different machines into one kind of sub network. Right, so in theory, if you just start all of these ROS nodes everywhere, they can all communicate with each other. But it could be possible that maybe you have a couple different swarms of robots and you want to keep those completely independent from each other. So only they can talk to each other and only other, say, sensors or machines on that network can communicate in that group. So what you can do is you can assign a ROS domain ID. And so you can do this at startup, or you can do it when you're running, say, particular nodes, is you actually connect it to that domain ID. And so then everything that's on that same network can communicate through those nodes, right? So in theory, what you can do is say we're all on the same Wi-Fi here, and we're all on the same domain ID, because I believe the VMs auto start you in a certain domain ID. So what you could do is, since we all have the same example code, is you could start the talker and somebody else could start the subscriber and see what your machine is printing out, right? So that's also a big power of ROS, is that you can have multiple machines that are talking on the same network, right? So that's something I'm hoping to have in the next lab. There's a little bit of a test, see if you can have one person, say, that is controlled of all of the turtle sims, and then each of you can connect to that one and have a bunch of turtles spawn that you're controlling on somebody else's machine. Right, so that's the hope. Unfortunately, I have one machine, so testing, multiple talking on one. Right, so we'll play that a little bit by ear, see how well that works with the virtual machines. But it just kind of highlights that there is a lot of power with this type of distributed communication that we can really leverage for these more complex infrastructures that we're putting into place. So that's the main thing I wanted to cover today. I said I'll double check my notes to make sure what it was that I copied wrong from where I was doing all of this last night, update those slides for you. The concepts are correct. My typing apparently is not. So I'll provide those additional details to you to make sure I can verify why that wasn't working. So next class, what we're going to do is talk about launch files. So launch files are a way that we can run a bunch of nodes all at once. And we can provide all of these parameters, any additional arguments, like all of those remappings, right? So if we start, say, 10 nodes and 5 of the nodes, we need to do a bunch of remappings of different topics and provide a bunch of parameters. That's going to get really nasty in the terminal, right? So we might have like 10 different tabs for each of the nodes that we opened, and each of those commands is going to have the ros-args of remap, parameter, right? Instead, we can have one command line and say ros2 launch this file, and it will do all of that at once. Right? So that's what we'll be looking at on Friday. If you haven't noticed, I've been updating the syllabus as well to reflect the changes that we've made to the outline. So next week, we don't have class on Tuesday because that's the Monday classes on Tuesday day. So if you have any questions in the interim, because hoping to give you lab 4 on Friday, so unfortunately we're kind of missing a day. So let me know if you have any questions or problems. And then we'll be looking at TF2, and then I'm hoping the week after that we'll actually get the hardware in here for you to play with. And that will be lab 5. It's actually just working with the robots. So once you get a feel for them, then your project will be based off of whatever it is that you want to do with those robots. And we're going to try, especially as we get closer, have more days where we just bring in the robots and let you play around with them. Like I said, we do have a space, but unfortunately we don't have an exclusive space. So I want to give you as much time as possible to be able to work with those. We might not have quite enough for everybody to always be working with the robots. And I know I already communicated to that to a couple of groups, but hopefully once we get some of the bugs fixed in a couple of them, we'll have more that we can bring in as we get through the semester. So definitely if resource scarcity becomes an issue, that will definitely be taken into account. I'm not going to make a lab do and then nobody had access to the robots, right? That's certainly not fair or productive. So definitely keep me in the loop if you feel like there's just not quite enough time to get the interaction with the hardware that you need, and we'll address that. Are there any questions, concerns so far? Okay. All right, so I'll give you the last, as we have 20 minutes or so to work on lab 3, I believe you're on right now. And let me know if you have any questions or problems with anything that you're going through with that.